Hello everyone. In this video, I am going to explain about electric field lines. Firstly, the concept of electric field was first discovered by Michael Faraday in the 19th century, and Faraday always thought of electric field lines which can be used to describe and interpret the invisible electric field. Electric field lines are used to describe the electric field around a system of charges in an easy way. Here, the strength of electric field is usually directly proportional to the length of electric field lines and also inversely proportional to the square of the distance. And electric field can be used in the pictorial form. The exact definition of this electric field lines means an electric field can be used in the pictorial form to describe the overall intensity of the electric field around it. It means an electric field can be used in the pictorial form to describe the overall intensity of the field. Intensity of the field means electric field strength or the strength of electric field around it in a pictorial representation is called the electric field lines. Here there are certain properties, rules and applications are there to describe the electric field lines. Electric field lines are imaginary lines drawn in such a way that their direction at any point is the same as the direction of the field at that point. Here, the first property is electric field lines go away from positive charge. Electric field lines move away due to the positive point charges and move towards due to the negative point charges. Here, there are certain properties of electric field lines. The first property is the electric field lines start from a positive charge and end at a negative charge. Always here the electric field lines start their journey from positive point charge and end their journey to a negative charge. This is the first property. Positive charges move away from the point charges and here the electric field lines move away from the point charge due to positive charge. Due to the negative charge, the field lines are move towards that charge particle. Here the first property is electric field lines start their journey from or start from a positive charge and end at a negative charge. Here you can see that here this is the positively charged particle and this is negatively charged particle. Here the direction of electric field lines. Electric field line means these are the imaginary path. These are the imaginary path or electric field line is an imaginary path along which a pre-unit charge tends to move. Here the line starts from a positive charge and end at a negative charge. Here all the lines starts their journey from positive point charge and their journey from negative charge. Here also the positive to negative. And the second property is a tangent. Here the second property, a tangent to a point on the electric field line give the direction of electric field at that point. Suppose here the tangent drawn at this point, here also the tangent drawn at this point or any line drawn in this imaginary concept, a tangent to a point on the electric field lines gives the direction of electric field at that point. Here the region around this charge particle or the region around this point charge is called electric field. A tangent drawn at any point, here also at any point. Suppose if you have drawn a small line, that tangent or that small line gives the direction of electric field at that point. And the third property is two electric field lines never intersect each other. ಯಾವುದೇ ಸಂದರ್ಭದಲ್ಲಿ ಎರಡು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸು ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗೋಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ, ಒಂದಕ್ಕೊಂದು ಓವರ್ಲ್ಯಾಪ್ ಆಗೋದಿಲ್ಲ. ಇಲ್ಲಿ ಥರ್ಡ್ ಪ್ರಾಪರ್ಟಿ ಹೇಳ್ತಕ್ಕಂಥದ್ದು ಕೂಡ ಅದನ್ನೇ. ಟೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ನೆವರ್ intersect each other. Here in this diagram you can see this. No one electric field lines intersect here. Two electric field lines never intersect. If two field lines intersect, then the positive charge at the point of intersection must move in two directions. It is not possible. It is always move only in one direction, that is positive to negative. Electric field lines always moves from positive charges to negative point charges. Two electric field lines never intersect. And the fifth property is the electric field lines do not pass through a conductor. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸು ಕಂಡಕ್ಟರ್ ಮುಖಾಂತರ ಪಾಸ್ ಆಗೋದಿಲ್ಲ. ಯಾಕೆ ಆಗಂಗಿಲ್ಲ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸು? ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಡು ನಾಟ್ ಪಾಸ್ ಥ್ರೂ ಎ ಕಂಡಕ್ಟರ್ ಬಿಕಾಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇನ್ಸೈಡ್ ದ ಕಂಡಕ್ಟರ್ is zero. Electric field outside the conductor is present. Here the region around the conductor or the region around the charge. The region around the charge, space around the charge is called electric field. But inside the conductor, the electric field is zero. Here the fifth property is electric field lines do not pass through a conductor. And sixth property is electric field lines can pass through an insulator because it is a dielectric medium. The electric field lines are always or can pass through an insulator. They do not pass through a conductor, but the electric field lines pass through a insulator. And the next property is electric field lines have a tendency to contract in length. This explains attractive nature of force between two unlike charges. Where the electric field is greater, at that region electric field lines are very close to each other. Where the electric field is very less, at that region electric field lines are far away from each other. And here the next property is the electric field lines have tendency to explain laterally. This explains the repulsive nature of force between two like charges. When two like charges are present, in that case electric field lines are repel each other. But one point charge is positive, another charge is negative. At that time, here the electric field lines have tendency to contract in length. And the next property is electric field lines are more crowded in a region of strong electric field. Where the electric field is very strong, the field lines are more crowded. Here, see here, the electric field lines, here the electric field is very strong. At this region the electric field lines are more crowded. Here electric field lines are less crowded in a region of weak electric field. Here the electric field is very weak because the electric field is directly proportional or inversely proportional to its distance. Inversely proportional to its distance. Already I have discussed here. Electric field or the strength of electric field is usually directly proportional to length of the electric field lines and inversely proportional to square of distance. Here electric field lines are more crowded in a region of strong electric field. Here at this region more crowded, but electric field lines are less crowded in a region of weak electric field. And next part, electric field lines are straight, equidistant and parallel in a region of uniform electric field. Here uniform electric field, the word itself says electric field can be divided into two types, uniform electric field and non-uniform electric field. Here uniform electric field means in this region electric field lines are always moving in the straight path with equidistant and parallel. The electric field is equally distributed throughout the region. Here this diagram, it indicates the uniform electric field. In this uniform electric field the lines are straight, equidistant and parallel in a region of uniform electric field. But here in the next point, electric field lines are curved in a region of non-uniform electric field. Already I have discussed in the basic class of electric field. Electric field lines are straight, equidistant and parallel in a region of uniform magnetic field. Electric field lines are curved in a region of non-uniform magnetic field. And next concept of your topic is electric field lines for different charge system, or electric field lines for a different charge system. In the first case, electric field lines due to an isolated positive charge, or field lines of a positive point charge. Here in this figure, this is the first diagram. In this figure shows the lines of force of an isolated positive charge. They are radially always outwards because small positive charge accelerated in the outward direction. Small positive charge always accelerated in the outward direction. They extend to infinity. The field is spherically symmetric, or it looks like same in all the direction as seen as in this diagram. And in the second point, due to an negative charge or field lines of a negative point charge, like that the positive point charge, electric field of a negative point charge is also spherically symmetric, but the lines of force the radially inwards. Here the lines of force the radially outwards due to this isolated positive charge, but here the lines of force radially inwards due to the negative charge. And in the third property, this is third property, due to an electric dipole or electric field lines of two equal and opposite charges. This is equal and opposite charges. These are the two charges, but here this is positive and negative. They are equal in field strength. They are equal in field strength, but they are in opposite charges. Here this diagram shows the field lines of force of an electric dipole, that is a system of two equal and opposite point charges plus or minus q separated by a small distance. They start from the positive charge and end on the negative charge. The lines of force seem to contract lengthwise as if the two charges are pulled together. This explains attraction between two unlike charges, and the field is cylindrically symmetric about the dipole axis. The field pattern is same in all the planes passing through the dipole axis. Clearly, the electric field at all the points on the equatorial line is parallel to the axis of the dipole. And the next concept, due to two equal positive charges. Due to two equal positive charges or due to two equal negative charges. Here this diagram shows field lines of two equal and positive point charges. Here the lines of force of two equal positive point charges, they seem to exert lateral pressure if the two charges are pushed away from each other. This explains the repulsion between the like charges. Here the first property is here. This diagram indicates this is due to an isolated positive charge. Here the electric field lines are moves radially outwards. In the second property, here the electric field lines are moves radially inwards. Here due to an electric charge, electric field lines starts their journey from positive charges and end to the negative charges. They are very more crowded in the region of strong electric field, less crowded in the region of weak electric field. Here this diagram, here it explains two equal and opposite positive charges. Here this is the positive charge. Due to this positive charge, electric field lines moves radially outwards. Here also this is the positive charge, electric field lines moves radially outwards. Or suppose if I consider negative charge, here the electric field lines moves radially inwards. Here also electric field lines moves radially inwards. In the fifth diagram, here this is in a uniform electric field. In a uniform electric field lines are moves always in a straight path with equidistant and parallel to one another. But in case of non-uniform electric field, here in this region the electric field lines are moves in a curved path. Thank you.